requested on Wyzant, going over a statistics problem, which to me looks like an application of normal distribution, standard normal distribution. And we're going to definitely get into how to solve this problem, but I'm also going to bring in a little bit more about what I've noticed in this question, asking for really two different types of situations. Now, the question requested is only showing the first part, so hopefully what I cover in the beginning here will help with the second part. It looks like there's another part to this question. So that's why at the top in the title, I have there X versus X bar. And those are the symbols representing a particular type of value concept within data, essentially just plainly data, but it's brought up in normal distribution. So let's actually read the question. We'll definitely double back and reread again when we answer the question, but I just want to get us situated in this context. So it says Business Weekly conducted a survey of graduates from 30 top MBA programs. On the basis of the survey, assume the mean annual salary for graduates 10 years after graduation is $122,000. Assume the standard deviation is $30,000. Suppose you take a simple random sample of 51 graduates. Now, this first question that was posted just reads, find the probability that a single randomly selected salary is less than $127,000. All right, so let's break down what's happening. Let's really understand, what are these two parts? What are they really asking for? And then we'll definitely get into answering the question. All right, so just some pointers real quick. The first thing is we have to apply this assumption because they don't even say it, but it's there, it's implied, right? But just so that is set for the work that we're going to apply. But we need to assume that this is approximately normal, okay? Again, they don't tell us, they don't even give us much, I would say much evidence. The only thing I would say is that when they first introduced this survey Business Weekly did, the survey size was 30, okay? So when you think about central limit theorem, hopefully by this time you've covered this point, this topic or concept, okay? The size of the sample makes, or let me say, allows there to be an approximation for it to be normal, if that makes sense, okay? So we're able to approximate it as normal. All right, so size does matter when it comes to surveys and statistics. It really, really does. The way that I see it as is you're trying to get, a good amount of data, right? And to hopefully represent it, make it as representative of the population as possible. So that's always the goal, because the goal is the population, to understand the population. Now, let me just say this too on that point. The first line there where it talks about how this survey conducted with 30 graduates, okay, that's actually going to be just extra information that we're not even going to use. So you may even think of it as it's throwing you off, okay, maybe, but just understand that that is not going to be involved because immediately afterwards it says assume. Okay, so we're going to treat the mean value that they give us and the standard deviation they give us as parameters, population values. So the mean here we will call then the quote unquote population mean. So we can label that as mu. Okay, and you'll see me rewrite this or have it rewritten later. And then the standard deviation here is the population standard deviation. This is really important because the symbols and the phrasing or the terms that we apply, it's going to lead us to a certain sometimes distribution specifically in just a certain way in which we look at the data, because it's either going to come from a population or a sample. So that has to be made clear in these type of problems. Now, like I said, looks like two different parts in this question, because at the end, before it gets into the questions, it says, suppose you take a simple random sample of 51. So when you see something like that, and then if you see, then a question following up about that sample, well, that is asking then to use the X bar value versus the first question that's we're actually going to answer. Okay, it says single randomly selected salary. Well, that reads as an X value. That's an individual data value versus a question asking about the sample of 51 graduates. That's your sample mean. Okay, so those are two different, slightly different distributions, still on the normal curve, but nonetheless going by different rules. So let me show you how that is. Okay, so I'm just going to jump over what I have there where it shows X leads to Z leads to area. So I'll come back to that in a moment for answering the question. But I just wanted to, again, really get out the way, really, flesh out like what is going on with this problem. So if we're dealing with just an X value, like the first question we're going to answer, that part that's in bold, bold text, then we're going to utilize the standard score or Z formula, X minus mu divided by the standard deviation, sigma. Okay, so that's just for an X value because all we're doing is taking a single value, single data point as it relates to that population or even from that population. Okay, but when we're dealing with an X bar value and they're talking about, you know, what is the probability that a sample mean of this value from a sample of this amount, okay, the formula is going to look a little bit different. Notice that in comparison to that of the X value, not only do we have an X bar that's going to represent a completely different type of number or context, right? Because it's coming from a group of numbers, right? Specifically the sample, right? So we have that, and we also have the sample value included. So that is a huge difference. Please pay attention to that. These two formulas are different from each other. They're referring to the same, concept that is standard score. And virtually that's what we're going to do. We're turning the X value or X bar value into a standard score in order to find the area, right? But it's on in different settings. Okay, specifically X bar is dealing with the central limit theorem. So this is where this is applied because we're no longer just talking about an individual value from a population. Now we're talking about, what is happening with the sampling distribution of the mean as it's coming from, the sample comes from the population, is trying to make estimation about the population, or we're just, talking about a sample to study the population. Let's just make it broad like that, right? And what's in the bottom of the formula is what we call standard error. And we could use a different symbol, such as sigma sub x bar or sigma sub x, I think, one of those two. Okay. That whole thing in the bottom of the fraction is the standard error because we're basically having to find a standard deviation specific to that sampling distribution. So hopefully that little review fires off some memory, some understanding of that, because at this point, especially with the way that this question is set up, you should have covered that topic. Okay, so now we're going to actually answer the question. And so right here, I like to always share this little flow map with students when I work with them on this type of question because it's important to know where you're starting and where you're going. And in between the start and the end is what I like to call the mediator. This is the mediator. Okay, we're using standard score to find or conveniently find an area for any type of normal distribution. We're again assuming this is in a normal distribution setting, this data. All right, so we're going to take the X value and we're going to turn it into a Z value. And you may have worked with the Z chart, so I will show that in this video. But I also show what you can do on the TI-84, and you can also do this on Excel. Okay, so whatever technology you use, whatever means you use to actually answer this type of question, please, do that. That's convenient for you. Once we find the Z-score, we're going to find the area, and depending on we're going to go over this again, but depending on the range in which we're looking at this area or of this area, that's going to show us the approach that we take to actually find it. Okay, so again, we have a mean of $122,000 with a standard deviation of $30,000. And we're asked to find the probability that a single value, single salary selected is less than $127,000. So we know what's given to us, all right? And given the situation, right, or rather the question, we're being asked about a single value and it's less than. So notice the notation, okay? The way that we have it set up is all values to the left, right? Or all values less than, all values below. All of that are synonymous to each other, and we're representing it by this setting, this whole statement, x less than 127,000, okay? So that means this is a left area that we're looking for, and I'm just gonna draw as fast as I can our curve to have a picture. Okay, so that's good enough. And so we're going to see, how this looks visually to help us with solving this type of question. Whoops, need to put that on the other side. All right, so x to the right of mean, because it's larger than the mean, right? And then we have our area, and this is probably not to scale. 127 might be a little bit closer, so just bear with me on that drawing. But we're gonna go off of the numbers. The numbers are gonna not lie. So I'm not trying to lie here, but yeah, maybe I should fix the numbers on the line, and that way it actually gets closer. And then I don't even know, honestly, like what is the size, like what it would look like size wise. And having worked it out, I know what the answer is. So it's actually going to be much closer. Let me see if I can get it as accurate looking as possible. But see, when you do your drawing, like how I said, don't worry about the scaling, or making it exactly right. It does not have to be perfect, honestly. What matters is your calculations, okay? So that's really the takeaway there. Okay, so the first thing we need to do is we need to convert x into z, because z is going to help us find the area conveniently. All right, so we're going to apply that formula. Remember, we're going to use the first one there for x. So we're going to plug in 127,000 and subtract 122,000 from that and divide it by 30,000. And let me just say, notice all three numbers are out to the thousands place. So you could just write it and type it in whatever technology you have, simply like this, and you're going to get the same answer, okay? But just to be thorough in this question, in this video, I'm going to write it all out like that so you see it. Okay, so you can do it by hand. It actually comes out to 1/6 when you use the fraction, but we're going to need the decimal. And it's approximately, I'm going to round it off to 2 decimal places. It's approximately 0.17. I'm going to 2 decimal places because the chart that I have goes out to 2 decimal places. You can see that up here when you consider the hundreds place. Okay, so that's why. And so now we're going to go ahead and deal with that. We're going to find the area given what we found for the z-score. And let me just explain real quick and review. What is the z-score? The z-score is a type of measure of position. All right, hopefully that makes sense when I say that. What that means then is when we're talking about a z-score, we're talking about how many standard deviations is the value we're dealing with away from the mean. And it looks like let me see if I can change. Yeah, it looks like it doesn't want to change from green, and I don't like when this happens, so I apologize. Okay, let me keep it going. So anyways, when we talk about a z-score, right, this is now in terms of the standard normal distribution, which I just write it as S and D there. But we're basically talking about the same value, but now in terms of a z value. And this is a position representing the position of that value. So 127,000 is at the position of 0.17, and then you could say it's 0.17 standard deviations away from the mean or the center. Okay, so that's all that means. Okay, and we are using it to conveniently find the area, but it's also useful to compare apples to oranges, this standard score, whenever you're trying to compare values that wouldn't be found on the same distribution, right? Or even from the same population, okay? When we use the z-score, we're able to compare them much easier. So that is essentially the point of that. All right, so we're going to use the chart here to find it, and we're taking the z-score and splitting it up into two parts here. That's how this chart works. So we have the ones and tens placed together, that's 0.1 there, and then we're going to find the hundreds place, 0.07, and we're going to find where they cross, where it forms, essentially the number 0.17. And where they cross is the area that is associated with that z-score. So the area is 0.5675. All right, so if I wanted to write it all together, I can rewrite my original statement for the area, but then show that it's equal to that of the z-score. Let me fix that. Okay, and then when I found on the chart, notice the chart, if you've worked with this kind of chart before, always remember that all area values out here, okay, all area values are to the left of any and all z-score that is basically found on the line. So we didn't have to do too much here. We didn't have to do too much here to actually find the area, because for other cases, like if it's to the right or in between or two tail, right, then you have to do some extra work. Okay, but this one was really easy. All we had to do was find the area on the chart and we're done. Okay, now I just realized that I don't have the picture, so I'm just gonna have to write it out here. Oh, now it changes. Thanks. Okay, so if you wanted to find this on the TI-84, for example, and I think you could do this on the 36, that's where it starts in that TI Texas Instrumentals Calculator series. In order to do these type of statistics functions, okay, the TI-84, TI-83, maybe the 36 can do this, but let's just go with the 84, for example, because this is the most well, I'll say the most this is popular, yeah. Most popular calculator. A lot of people get the 36 though. But with the TI-84 or any of the others that can do this, on the TI-84, you have to click second vars to get to the distribution menu. So if you have your TI-84 with you, you can see on your calculator the button vars, and right above it is, in some other color, distribution, DISTR. So the second button is your shift key on the calculator. It's going to be able to give you the command right above that button. Okay, and so once you click into that, you're going to find the function to use here, normal CDF. All right, and it should be a separate menu that comes up where it asks you to plug in some values. So I'm going to actually write how it would look on the main page when you paste it. But you'll see a lower space, so that's going to be, just leave it. It's maybe already set this way. You'll just leave it at that really large negative number, because that is representing virtually infinity. And that's how the curve works anyway. It's a continuous curve, so it goes to infinity in both directions. But hopefully you learn too that the curve, as it basically goes past or is at 4, positive 4, negative 4 on the x-axis, it's basically no space between the curve and the x-axis line. So at that point, there's no area that's substantial, okay? So the lower value is going to be that really large negative number. The upper value is going to be the z-score that we find. And I recommend leaving it as a z-score for the boundaries and mu and sigma, because the calculator is actually kind of following the chart here. All right, so if you're doing this on your calculator right now in this video, that's great. You're going to see that we get the answer 0.5675. Okay, so again, we have the lower boundary which is virtually infinity, the upper boundary, which is the value we're going up to in our curve there, 0.17. And then we have mu, that's going to be 0 anytime we're dealing with standard normal distribution. The standard normal distribution is always mu is 0 and sigma is 1. And then 1 sigma there. So once you plug that in and calculate it, you're going to get the answer we found. Okay, so I really hope that this answered that first part of the question. And just remember, um, the last part in that paragraph is asking you to do pretty much the same thing, whatever the probability in question is, but you're using this other formula, okay, pertaining to central limit theorem. So yeah, I really hope that this answers your question, and answers any other questions you had on this topic and concept of normal distribution. And please let us know if you do have any other questions, and we will see you next time.